In this video, I'll be going over how to solve a right Riemann sum problem and a left Riemann sum problem. So first, let's go over the first question. It shows us this table, and it says, unless otherwise noted, the domain of function f is assumed to be the set of all real numbers x for which f of x is a real number. Right? So now let's go to b, given that information. Use a right Riemann sum with the 5 subintervals indicated by the data in the table to approximate the integral from 2 to 14 of h prime of t dt. Indicate units of measure. Right, so now let's look at the data. In order for us to do a right Riemann sum, it also tells us it's 5 subintervals, right? So we go from 2 to 4, 4 to 5, 5 to 8, 8 to 10, 10 to 14. That gives us 5, right? 2 to 4 is 1, 4 to 5 is 2, 5 to 8 is 3, 8 to 10 is 4, and 10 to 14 is the 5th subinterval. So let's write it out. So since the first subinterval is between 2 to 4, we just take the rate of change, or the difference between it. Right, so what is 4 minus 2? 2. Or the delta x value you might see in other places. So the 4 minus 2 is 2, right? And we have to multiply that by the rightmost, let's say, term in this case. So since it's between 2 to 4, the rightmost number is 0.6. So it's 2 times h prime of t, or in this case, h prime of 4. Then we add it by the next interval, which is between 4 and 5. So in between this interval, the difference between 5 minus 4 is 1. So we put a 1 as the coefficient. And then we multiply that by this h prime of t value of the rightmost part of the interval. So between 4 or 5, the most right would be 5. Think of it like a number line. 5 is more right than 4. So we'd only focus in this case of what the value for 5 would be. So let's write down 1 times h of 5, h prime of 5. Right now let's add so we've already done 2, right? The first subinterval is done, 2 times h prime of 4. The second subinterval is done, 1 times h prime of 5. Now let's go into the third subinterval. So since we've done 2 to 4 and 4 to 5, let's do 5 to 8. So the difference between 8 and 5, so 8 minus 5 is 3, times h prime, and if I'm looking at the farthest between the 5 and the 8 is farther away from 0. So let's put 8 right here. Now let's add the fourth subinterval. That's between 8 to 10. So the difference between 8 and 10 is 2. So we write that 2 times, what's the farthest from 10 in this case? Between 8 and 10? 10. So it's h prime of 10. Then we add the last subinterval, which is between 10 and 14. So if we subtract 14 from the 10, if we subtract 10 from the 14, we would get 14 minus 10 to equal 4. And since 14 is the farthest from 0 in the subinterval, we would put h prime of 14. So let's add all of this together. So starting from the left, 2 times h prime of 4. So that's 2 times 0.6. That is 1.2. Then we add 1 times h prime of 5. That's just 0.7. Then we do 3 times h prime of 8. So what's h prime of 8? So 3 times 1.4. 4.2. Right, so we got that. Now we add that by 2 times h prime of 10. So that's 2 times 2.3. It's plus 4.6. Now finally, what is 4 times h prime of 14? So looking at the table, it shows, if I go to 14, h prime of 14 becomes 7.7. So 4 times 7.7 is equal to 30.8. Right, now what does this equal? So let's add this up. 30.8 plus 4.6 plus 4.2 plus 0.7 plus 1.2. And we get our final answer of 41.5. Now, since that's our approximation, we have to look at if we're missing anything in the question. So since it's telling us in units of measure, that's just feet per hour. Okay. Now let's go into the second question. Is the approximation in part B, or whatever this was, an overestimate or underestimate for the integral of 2 to 14 of h prime of t dt? And let's look at the table for a second. Is it increasing over time or is it decreasing? And if we look at the values, every time we go up in hours, the h prime of t value goes up with it. So that's an increased slope, because as the more hours goes, the more feet per hour you get. So it's going like this, right? Increasing. So now, since this is a right Riemann sum, let's load dots over here. Since it's a right Riemann sum, we're coming from the right. So let's try to just draw a straight line from here. And let's say we're trying to compare a point on this side. This is the end of the subinterval, let's say, or the start of the subinterval, and this is the end. So left, right. So this is the left side. So the next point is here, let's say, right? So the left point is right here. So since we're doing a right Riemann sum, we start from the right, go up, and then turn left in a straight line, and then go right down to connect to that point. So as you can see by this graph, we have a lot of empty or extra space on top of this slope of ours, which means it is a very big overestimate. We don't know how big it is. It's just based on this graph I made. It looks like a very big overestimate, but I'm not sure. So the main takeaway that based on this question is that the approximation is an overestimate because the slope is increasing because the slope is increasing for a right Riemann sum approximation. Right, Riemann sum. Right, okay. So now that we've got that done, let's move on to the left Riemann sums. So reading the question, it says, use a left Riemann sum with the 4 subintervals indicated by the data in the table to approximate the integral from 2 to 10 of L prime of t dt. Indicate units of measure. So how to solve the right and left Riemann sums are quite similar, except if we go back a little bit, the right Riemann sum focuses on the rightmost, right? So let's say a subinterval between 2 to 4. The rightmost is 4. But if we were doing a left Riemann sum, we'd be focusing on the leftmost value, or the value closest to 0 in this case. So that would just be 2. So let's do this left Riemann sum problem. So the interval, since it's giving us 4 subintervals, let's count this out, right? So 2 to 4, 4 to 5, 5 to 8, and 8 to 10. Since we have 4 bumps over here, we know we have 4 subintervals. So the first step is the same as the right Riemann sum. In the first subinterval, what is the difference between the two values? Which in this case, the first subinterval is between 2 to 4. The difference is 2. So we write that. 2 times what exactly? So we have 2 times, in this case, it'll be L prime of 2. Now we keep going. Now in the subinterval of 4 to 5, we would subtract 5 minus 4, which gets us 1. And now when we're looking for what is our L prime of t value, it would have to be L prime of 4, since it's closest to 0 in comparison to 5. So it's 1 times L prime of 4. Okay. Now we add that by our next subinterval, 5 to 8. So the difference between 8 and 5 is 3. So 8 minus 5 is 3, right? That's our third subinterval. And we multiply this by L prime of 5. Now we add our final subinterval. Since we have 4, we got 3 so far. So our fourth subinterval, as demonstrated by this last little hump right there, 10 minus 8. So that's just 2. And which one is farthest from 0? Which one is closest to 0? In between 8 and 10. Right? 10 is the farthest, and 8 is the closest. So since this is a left Riemann sum, we want whatever value is closest to 0. Or the initial value, what you're trying to plug in. So since we're plugging in either 8 or 10, the initial value is 8, so you're trying to plug that in, or plugging in 10. But since 8 is closest to 0, we plug that in to the L prime of t. So 2 times L prime of 8. And we stop there. We don't do anything with a 10 because it is the farthest to the right, so we exclude that. And we include just this 4 right here. And if we go back up again, we had excluded this leftmost point, the 0.3. So kind of along the same lines as that. So let's try to multiply this step by step. What is 2 times 1? 2. Then we add that by 1 times L prime of 4, which is 0.8. Add that by 3 times L prime of 5. So 3 times, 3 times L prime of 5, which is 3 times 0.7. We get 2.1. We add that by 2 times L prime of 8. So 2 times 0.4 is 0.8. Okay. So now we got all of our values. Let's add them up. So 2 plus 0.8 plus 2.1 plus 0.8. 5.7. Is our final answer. And units of measure is feet per week this time. Feet per week. Now scroll up. 41.5 and 5.7. Actually, that's a bad example since they're different questions. So, right? So if you got 41.5, you're right. And if you got 5.7, you're doing good. All right, now let's look at the final question. Is it an overestimate or an underestimate? So let's look at our table. It's showing us that over time, as the t increases or the amount of weeks increases, the number keeps on going down. So the L prime of t value keeps going down as the weeks keep going. So our x value is increasing, and our y value in this case is decreasing. So it is a decreasing slope. So let's draw and see what it looks like. So it's decreasing, and we are a left Riemann sum, correct? Going up, so we're going to draw this little line thing right here. We're going up, right? We stop here, and let's say we want to end the subinterval here. So we move this way, then we go down. So since this is a left Riemann sum, and it's decreasing, we have so much empty space up here, and so much of an overestimate. So this 5.7 feet per week is an overestimate. So we can write this approximation is an overestimate. This approximation is an overestimate because the slope is decreasing for a right Riemann sum. Oh, sorry, a left Riemann sum. For a left Riemann sum. Okay, that's it. Thank you for watching today's video. I hope you enjoyed it, and don't forget to like. Thank you.